Welcome back to You Revise, where we talk about everything exams. Let's take a look at question 12 from the 2016 exam. It reads the best definition of the equivalence point in an acid-base titration is the point at which, right, we've got a list of answers there we're going to go through. According to the examiner, 75% of candidates got this question right, which means 25% did not do very well. It's a good percentage to have gotten this question right, but what I think is probably most students did not know the definition of equivalence point because this was a recall question where you just have to know what the term equivalence point means. Now, what is the equivalence point? Equivalence point is when you mix the right stoichiometric ratios of acid and base. So for example, if I'm reacting sodium hydroxide and HCl, right, I get sodium chloride because this is an acid-base reaction plus water, a salt and water. If I check, let's check if this equation is balanced. 2 hydrogen, 1 oxygen, 1 oxygen, 1 sodium, 1 chlorine, 1 chlorine. This equation is perfectly balanced. So what it means is this ratio of combination between sodium hydroxide and hydrochloric acid is maintained regardless of whatever the amount you mix. So if I've got a beaker which has got, let's say, 20 mils of 0.2 moles per liter acid, and I've got another beaker which has got 30 mils of 0.2 moles per liter or 0.1 moles per liter or let's just leave it at 0.2 moles per liter. Right, the moles that are going to be required here must be the same as the moles of sodium hydroxide, because we can clearly see that here how many moles do I have. If we say moles is equal to concentration times volume, if we change this one to liters, because our concentration is in liters, it's in moles per liter, I'm going to end up with 3 times 10 to the power minus 2, so that's 30 divided by 1,000, we get 0.03, times the volume, which is 2 times 10 to the power minus 1, I end up with 6 times 10 to the power minus 3 moles. Now, and for the sodium hydroxide, I've got 20 milliliters, which is, if we change that to liters, because our concentration is in moles per liter, it becomes 2 times 10 to the power minus 2. 20 divided by 1,000 is 0.02 times 2 times 10 to the power minus 1, which is equal to 4 times 10 to the power of minus 3 moles. Now, looking at this here, according to our ratio here, if I've got one, each time I mix HCl and sodium hydroxide, they're going to react at a ratio of 1 to 1. This ratio here is not 1 to 1, okay? Because the equivalence point is going to be reached at the time when I've added, if I've got sodium hydroxide here, for this reaction, the equivalence point is going to be when I've added 4 times 10 to the power minus 3 of acid, moles of acid into the sodium hydroxide in the conical flask. Let's say I'm delivering HCl from the burette. The equivalence point is when I've added the right stoichiometric ratio, which is governed or guided by the balanced equation we write. It doesn't matter how much you have, which means any other hydrochloric acid I have in the burette is going to stay there. So I'm going to remain with another like 2 times 10 to the power minus 3 moles of acid in the burette. So that's what equivalence point means. There's another term as well which you need to know. It's called the end point. The end point is, let's say in here I've got a universal indicator. right? There are not a universal indicator. I've got an appropriate indicator, not a universal indicator. For titration, please guys, I apologize for using the term universal indicator. For titration reactions, we do not use universal indicator. There are so many reactions, methyl red, methyl orange. Another thing that you need to know, I'm sure we're going to come across such a question. I'll expand on that when we get to that question. I just don't want to make this video too long. Now, endpoint is when the indicator changes color, right? And you'd find that the endpoint is slightly above the equivalence point, just by a fraction or fractions of milliliters. That's where we have the endpoint. That's when we stop. So the endpoint, if we select an indicator, the end point of that indicator must be as close as possible to where you think the equivalence point is going to be. So the end point is when the indicator changes color, and the equivalence point is when you've added the right stoichiometric ratios. Now let's take a look at the answers. A reads, the end point is a point at which the indicator, equivalence point is a point at which the indicator changes color. No, we say that's end point. This is end point, so that's completely out. B, the volume of acid equals to the volume of a base. No, the reaction is not per volume, it's per moles that you add, because substances combine in terms of moles. So it's not the case, because if you've got different concentrations, you're going to be adding different volumes. So for example, if this acid had a concentration of 0.1, right, it just simply means I'm going to be adding more HCl here because I have a lower concentration, but it's not that I'm going to add the same volume. No, you end up using a lot more volume of that because you need to add more moles in there in the conical flask to neutralize. So it's not per volume, it's per mole. Now, the pH of the solution is 7. Not all neutralization reactions end at a pH 7. Some neutralizations have got an acidic endpoint, some have got a basic endpoint, some have got a neutral endpoint, and so the pH is not always 7 when you mix an acid and a base. So answer C is incorrect. D, mole ratio of acid to base is equal to their stoichiometric ratio. That's correct. So the molar ratio must match the stoichiometric ratio. If it was 1 to 2, you need to match that 1 to 2 stoichiometric ratio to reach equivalence point, which means D is our correct answer. Thank you again for taking time to look at this video. I hope my further explanations were helpful to you. If it was something that you already knew, perfect. Repetition is the mother of skill. I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.